The first topic we'll see today is exponents and radicals. All right, so I always try to provoke my students to think about what kind of questions you'll be able to deal with in the SAT at the beginning of each lesson. So if we talk about the theory of exponents and radicals, what kind of questions are we aiming at? These questions, for example, take a look. Let's continue with our first point. So we're talking about exponents and radicals, okay? With exponents and radicals, the theory behind these topics, you'll be able to do questions like this. So do you want to measure your strength? You can try, for example, question or example 1. As you know, the SAT has several question formats. One of them is the multiple choice, in which they present you with a question and 4 answer choices labeled A through D. Okay, so let's try example 1. Okay, you can see in this question says if 3 up to x plus 2 equals y, then what is the value of 3 up to x in terms of y? That's a question. So can you try? I'll have just 1 minute for this because in the SAT you don't have that much time to solve the math questions. So let's see what you can get, and you can send me your answers on the chat, no problem. Okay. How can we get to the correct answer? Okay, we'll see. And as you can see, examples 2, 3, and 4 all deal with the notion of exponents and sometimes roots, right? For example, in example 4, you can see an expression that says the 4th root of x up to 5. And then there are 2 other roots in example 5. So how do we deal with this? What is the theory that we need to know and memorize about this? Let's see, okay? The important thing here, okay, is that first you need to memorize these laws of exponents. Thank you, Axel, again, for your response. Later on, we'll come back to these questions. Don't worry, we'll see the correct answer to each of them. Okay, so the laws of exponents are some properties, right, that determine how exponents and also roots behave. For example, one important law is that exponent 1 applied on any number or algebraic expression yields the same value of the original expression. X up to 1 is always x, no matter what x represents. For example, 3 up to 1 will always be 3. And what about exponent 0? Exponent 0 applied on any number different from 0 yields the result of 1. So for example, 3 up to 0 equals 1. Okay? Then what about, for example, the multiplication of 2 powers? As you know, a power is this, right? This setup of 2 numbers together, this is called the base. This is called the exponent. But the whole thing is called a power, the result of that operation. So when you multiply, for example, 2 powers of the same exponent, or sorry, the same base, right? For example, x up to exponent m and x up to exponent n. What is the result of that multiplication? Well, it's another power of the same base, that is x, with exponent that is actually the sum of the exponents of the respective factors, right? M plus n, that is the resulting one. For example, if you multiply 3 up to 4 times 3 up to 5, what you get is 3 up to 9. Kind of intuitive, right? Yes, because we have the notion that an exponent, what it represents is the number of times, when the exponent is an integer value, is the number of times that a factor has to be multiplied by itself, right? So when you say 3 up to 4, that is 3 times 3 times 3 times 3. That is 3 multiplied by itself 4 times. Okay? So it makes kind of sense when you apply this property, adding exponents in a multiplication of powers of the same base. Now, when you divide two powers of the same base, okay, you have this. The result is another power where the exponent is the difference of the exponents of the corresponding dividend and divisor. So if you divide 3 up to 7 by 3 up to 3, you get 3 up to 4 because 7 take away 3 is 4. All right? You have also the property called the power of power. So if you raise x up to m to the power of n, so what you get is another power where the exponent is achieved by multiplying these two, m times n. So for example, 3 squared up to 4, that is 3 up to 2 times 4, that is 3 up to 8. And so on. We have another property here. A power of a product can be interpreted as the product of two powers where each of the factor is applied the same exponent. Okay? For example, 2 times 3 up to 3 is the same as 2 up to 3 or 2 cubed times 3 up to 3 or 3 cubed. This is another property. If you apply an exponent to a quotient of two expressions or numbers, you can apply the exponent to the numerator and to the denominator and get this. So 2/3 up to 3 or 2/3 cubed is 2 up to 3 divided by 3 up to 3. Now, this is a really interesting part. How do we interpret negative exponents? Negative exponents can be interpreted like this. If you have a number raised to a negative exponent, that can be interpreted as the power with a positive exponent of the inverse or the reciprocal of the expression. For example, if you have this 3 up to -4, imagine you have 1 over 3, that is the inverse of 3, up to 4, positive 4. But of course, if you raise this, 1 up to 4 is simply 1, so 3 up to 4, and you get this, right? So that's a way how you can interpret negative exponents. Okay, so let's move on. Using these properties, okay, be careful how you interpret certain constructions. For example, here, -3 up to 2 or -3 squared and the inverse additive of 3 squared are two different things, although they are similar in the form, right? But what's the value of this? Anyone?
9.
9, very good. This is 9 because it represents -3 times -3. The factor here is -3 multiplied twice. While this one, what is the value of that?
9.
-9. Thank you. Thank you all. You all responded. Okay, so it's different, right? Okay, and well, it's possible that sometimes these two expressions, although different in form, can yield the same result. For example, what is this? -2 cubed.
8.
8?
Oh, I'm sorry. What?
Is that correct? This one,
No, that's
-2
-8. I'm sorry.
-8. Very good. -8. And what about this one here? Is it different?
No.
Or the same?
It's the same.
Same, right? Very good. Both are the same, yes. In this case, because here it means the inverse additive of the power 2 times 2 times 2, which is actually, this is 8, right? So it's -8 in here. Okay, so considering this, we can try a few exercises, okay? So you can try this one, and well, in your, if you have a notebook or something or somewhere to write, you can note down numbers from 1 to, okay, like 27. Let us do just, you know, some of them, okay? In order to have more fun and not to delay too much here, we'll do the odd numbers, okay? 1, 3, 5. The rest is your homework, okay? You will have this homework. Of course, not the only homework you will have. You will have more, don't worry. You will have plenty of homework to practice a lot. So, what about number 1? What is number 1? What is this?
1.
1. Positive 1 or negative 1?
Positive.
Positive 1. Very good, right? Just 1. What about number 3?
Positive 1.
Okay, that's right. Positive 1 again. Okay, let's ask Luciana, okay? Let's see, Luciana. Number 5, what is number 5?
Also positive 1.
Positive 1?
Yes.
Okay, good. Let's see number 7. Axel, can you please? What is number 7?
Okay, hear me? First of all.
Now I can hear you. Yes,
Oh,
you
yes? Oh, I think it's -1. I think.
-1. Okay, great. Good. Okay, Fabiana, please, number 9. Can you help us? What is the value of that power? All right, thank you, Fabiana. -27, okay? Yeah, Fabiana volunteered her response through the chat, okay? Don't worry, guys, if you didn't listen to her. She's active in class. Okay, let's try now something a little bit more challenging. Number 13, people. What is number 13? Okay, you can try, calculate, and anyone can intervene here, can participate.
-72.
-72. Okay, let's write Madeleine's idea. Anyone else concurs?
It's 17 too.
Oh, sorry, 72. Okay, it says 72. Anyone else concurs, agrees with Madeleine?
I agree, teacher.
Luciana, okay, great. So Madeleine, Luciana, who else? This part easy, right? 8 times 9, and this one is -1 because of the odd exponent. Okay, -72. Okay, so you know, this is it. Of course, expressions like this, you don't need a calculator, okay? So for some problems, you can do with a calculator. Okay, let's see some interesting question now. Okay. Sorry, a question of exercises. Now let's raise, the level a little bit, because now we'll deal with variables, okay? Variables. Algebraic expressions with variables, sometimes one variable, two variables, or more. For example, you can see that the product of 3x squared times 2x cubed equals 6 times x up to 5. Because in this kind of expressions, you multiply coefficients on one side, and you multiply like terms on the other. In this case, as we have x squared and x cubed, you can multiply 2 powers of x, no problem, x up to 5, and 3 times 2 is 6, so 6 times x up to 5. Now here, the condition in this set of exercises is that we rearrange the expressions so that the answer contains only positive exponents. How is that? Example, in number 2, you see that the product of 2k up to -4 and 4 times k squared equals 8 over k squared. Why? Because what we've done here is to say we multiply 2 times 4, and that is 8, of course, but then k up to -4 times k squared, if we use the concept of the multiplication of powers of the like bases, we just add the exponents, right? So -4 plus 2 is -2. This would be k up to -2. But we said that a power with a negative integer exponent can be interpreted as the inverse of the respective power with the corresponding positive exponent, 1 over k up to 2 or 1 over k squared. So multiply by 8 would be this, right? So how can we rearrange this? What would be the final value for number 3? You can try, please. You can try to write it too, no problem, on the chat. Oh, something happened here. Madeleine suggests this answer. I will write it over here. 15 divided by x squared. Is that correct? Thank you, Madeleine, for your participation. Now, let's see if everyone agrees. Anyone agrees with Madeleine's response? Axel too. Okay, take a look, guys. See this. If I multiply, okay, we can regroup the terms in this multiplication like this. Okay, we can say, oh, okay, Madeleine, you change your response. Okay, you have the right to, no problem. We can have second thoughts. If you regroup the coefficients and then regroup the powers like this. So you multiply this, you get 15, no problem. And x up to 4 times x up to -2, because it is a product, you add exponents. But this is an algebraic sum. 4 plus -2 is just 2. So this would be x up to 2. The expression would be 15 times x squared. All right? Okay, we can try number 4, please. Remember to follow that strategy, right? Separate the coefficients on one side, algebraic terms or variables with exponents on the other side, and then multiply numbers with numbers, variables with variables. Okay, Luciana, thank you. Yeah, it's interesting. Take a look, guys. If you multiply 7 times -3, of course, you get -21. But then m cubed times m up to -3, if you add the exponents, you get what? You get 3 plus -3, that is 0. -21 times n up to 0, but we said that any number up to 0 is 1, right? So -1, -21 times 1, -21. So it's just a number here. Okay, but let me clarify here something for you. Here, let's assume that m is a variable with some value different from 0, right? Because there is a discussion in math that this expression 0 up to 0 is not defined, okay? We don't say that 0 up to 0 is 1. Okay, it's undetermined because normally it doesn't mean anything in many contexts. But if it is a number different from 0, okay, if it is a number different from 0, such as, for example, 14 up to 0 would be 1. And why is that? Because if you, for example, do this division, 4 up to 7 divided by 4 up to 7. Of course, if you divide the number by itself, you always get 1. But by the properties of exponents, this would have to be 4 up to 7 minus 7. And so this would be 14, sorry, not 4, 14 up to 0. And so we would be equating these two, right? That's why any number different from 0 up to 0, it's like 1. So let's do one more. Okay, how about this one, 15? Let's jump to number 15, another example. What would be the result of simplifying exponents there? Okay, so what do we get when we operate this? Number 15, we said, right? So first, notice that there is no coefficient but 3. So These three must remain. So what about the x? Okay, we have x up to 4 in the numerator, but in the denominator, we have a power of a power. We said that the property that applies is we multiply the exponents to get another power with the same base and a compound exponent, which is -2 times 2. In other words, -4. But then we said that there are two possible ways to interpret this. Okay, here at this point, oh, sorry, it's like moving. Let's say something here. For example, you might say that x up to -4, since it is, right, denominator, like this expression, you could take it up to the denominator by changing the sign of the exponent. So say that this is the same as 3 times x up to 4 times 1 over x up to -4. And so this would be the same as saying 3x up to 4 times x up to 4. Because you can understand that this negative exponent can be interpreted as something like this, -4. So would be the inverse of this, like this. Okay, if that's the case, this would be x up to 8. So 3 times x up to 8. Another way to view this would be to simply apply the rule for the division. If you do the division of these two powers, then what happens? You would have to do the subtraction of the two exponents. That is to say, 4, take away the exponent of the denominator, -4. So it's a double minus sign, right? So this is a sum, actually. 4 plus 4, 8. So that's it. Okay. Let's now see something related to here. We go back to these examples 1 and 2. Okay, how can we actually solve this one without doing so many steps? That's a point. Notice that we are asked to find the value of 3 up to x in terms of y. So perhaps somebody would think, okay, maybe I will find first what is x in terms of y, and then I will substitute here the x and get an expression. Yeah, it's possible, but that would be actually very long. Instead, what can we do? For example, here, can we express this power as the product of two powers? Which two powers would they be? Okay, thank you, Axel. Very good. That's exactly what happens here. 3 up to x times 3 squared. Look, x plus 2 is this, right? The exponent here. So it's like we are doing this property here. But this property here, but in this direction, backwards, okay? We are opening this expression as a product of two powers. So that's exactly what we're doing here. So as you can notice, this is equal to y. And because this is a number very well known, okay, it's 9. So 3 up to x times 9 equals y. And from this expression equals y over 9. Okay, what about number 2? If 3 up to a plus 1 equals 3 up to -a plus 7, what is the value of a? So here there is a fundamental property that we saw also a moment ago. So actually we didn't see this. What happens if you have two powers of the same base, right? And they tell you that these two powers are the same in value. So what follows from this equality? If two powers of the same base, notice the base is here, a, and on the right is also a. So if we have two powers with the same base, and these two powers are equal in value, then it follows that the exponents must be equal, okay? So you can use this in order to solve the question in the example 2, this one. Okay, thank you, Madeleine and Axel. Very good. That's a correct answer. Here, you have to yield a value. You cannot choose from 4 alternatives. That is another format in the SAT that they will present you with a question, and then they present you with a little box where you have actually to type the correct value. Okay, so following the idea mentioned, we have two powers of number 3 here. This is another power of number 3, and the two powers are equal. So it follows that the exponent of the power on the left must be the same as the exponent of the power on the right. So if you equate these two exponents, what you get is a simple linear equation, right? With the variable a. So you can add a on both sides and you get 2a plus 1 equals 7, then take away 1 on both sides, and then 2a equals 6. So from this, a equals 3. All right, let's see some more theory here. Oh, some more examples. Okay, try this one now. Example number 3. If 2a take away b equals 4, what's the value of 4 up to a over 2 up to b? Please remember that in the SAT, when they ask you in a question about the value of some expression, value always means numerical value. It's a number, right? Not a variable or an algebraic expression. It must be a number. So the result or the response to this question must be a number, okay? Let's see. Probably you might be thinking that if you were able to find the individual value of A and the individual value of B somehow, you could insert the values in the fraction and then calculate it very easily. Yeah, but you are not given the individual values of A and B, so how can you get to the right answer? This is a challenge, right? Try to view 4 up to A with a different form as a power of some other number other than 4. Think about it for a moment. Maybe you can get to the right approach. Okay, Fabiana, nice try. But I'm afraid it is not either. Okay, your answer is not the right one. Okay, let's see, people. Take a look. Isn't it true that 4 up to a is the same as 4? What is 4? It's the square of 2, right? Up to a. But using the power of a power property, we can express this as 2 up to 2 times a, because you just multiply these two exponents. So now let's reformulate the expression. It's 2 up to 2a over 2 up to b. Now you have a division of two powers of the same base again, so you can apply the property and say that 2 up to 2a minus b, right? You subtract this exponent and this exponent. This is the result of this division. And this, what is this? Well, according to the premise, this if clause at the beginning, it says that the value of 2a minus b equals 4. So this is the same as 2 up to 4. All of this is 4. And what is 2 up to 4? Obviously 16. The right answer. All right. Any doubts? Any questions? Clear? Solution clear? Too difficult? Okay. Yes, I think once you see the steps, yeah, it's easy, right? One always, remains thinking, how come I didn't think of this first? Yes, it doesn't matter if you didn't realize from the very beginning what was the approach. But now that you see again something similar, remember what we tried here. Okay, that's the best way to improve little by little. Okay, now let's continue. Let's keep going. Let's now understand and interpret fractional exponents. How do you interpret this? X up to A over B. Okay, the best way to interpret this is always as a root of a power. That is, this root where the radical index, the number that goes here, would be this one, the denominator, that is B, and the power of this number would be x up to this number here, the numerator. So when you see a fractional exponent a over b apply on some base, x up to a over b, this is the bth root of x up to a, okay? For example, the x up to 1/2, that is the square root, because of the 2 below, of x up to 1, okay? And x up to 1 over 3 equals square or cube root of x up to 1, right? Because here the 1 as an exponent means nothing, right? So same as I said, x up to 2 over 3, that means the cube root of x squared. So what would be, for example, here? What would it be this as a fractional, as a power with a fractional exponent? The x root of a up to y. What would be the exponent of the power? A up to what? Do you think?
Y over X.
Very good. That's it. Okay, so please try to use this property when you deal with questions like this. Take a look at this one. Which of the following is equal to the 4th root of x up to 5? Yeah, now that we know the property is immediate, right? You can tell. Which one is the correct choice?
D. I'm sorry. D. I'm sorry. D.
D or C?
D.
Take a look. We said that the form
I'm
is like
sorry.
this.
I'm sorry. I said C. I said C at first, and then I changed to D, but it's C.
Yes, this is it, right? Remember, the exponent of the power in the radicand, that is the numerator of a fractional exponent. The radical index, that is the denominator of the fractional exponent. So x up to 5 over 4. Okay, now here, you know, sometimes they ask you to simplify roots like this. How would you simplify this root in terms of roots or square roots of lower or smaller numbers, such as 2 or 3? I think the best approach you could try is perhaps a prime factorization. For example, you know that 48 can be actually broken down like this, right? 8 times 9. But 8 is 2 cubed and 9 is 3 squared. So when you take the square root of 2 cubed and 3 squared, you can always separate for any power in the radicand, separate the highest even exponent. For example, the highest even exponent for 3 is 2. Yeah, so you separate this and it's like this, right? This is like a square root of 2 cubed times the square root of 3 squared. If you apply the property of the fractional exponent, this would be 3 up to 2 over 2. That is to say, simply 3. Something like this, right? 2 over 2 is 1. Okay, what about this one? From this power, you can separate the highest even exponent.
48 is 8 times 9.
Oh my God. Yeah, I was thinking of 72. Okay, please. I don't want to repeat the same example on the right. 72, okay?
Sorry.
72. So the square root of 72 equals this. Yeah, so what would it be if we simplify it? Okay, take a look. Once we take out the 3, we get the square root of 2 cubed. But 2 cubed, you can separate like this. It's like a product of 2 squared times 2. And this root of a product is also the root of 2 squared times the root or the square root of 2. So now you have this. This one, again, with this one, you have 2 times the square root of 2 times 3. So 3 times 2, 6 times the square root of 2. You can always do that. No matter what is the number, from the prime factorization, you can always separate first the power with the highest even exponent. For example, if they give you, imagine this, 2 up to 25 times 3 up to 15. You can always say, oh, this is the same as 2 up to 24 times 2, 3 up to 14 times 3, right? Because 24 plus 1 is 25, 14 plus 1 is 15. So once you have this, split, right? Split the roots of the product. So the square root of 2 up to 24 is 2 up to 24 divided by 2. That is this fractional exponent times the square root of 2 times 3 up to 14 divided by 2, because here is a tacit 2, right? It goes without saying or without writing. And then again, the square root of 3. So what do we have? 2 up to 24 over 2 is 2 up to 12. 3 up to 14 over 2, 3 up to 7. Okay, it would be this times the square root of 2 times 3, square root of 6. So that's how you can achieve the reduction of these kinds of roots. Okay, let's move on. Can you try this one? Example 5.
Sí.
Okay, thank you, Madeleine. What about the rest of the class? Fabiana, did you say B? No. No, that was your last response, right? How do we get the value of X here? Okay, some people would do something clever, perhaps raise everything to the exponent 2 on both sides. For example, this. If you take squares on both sides, that's valid, right? In an equation, you can do that. So applying the exponent to each factor is 16 times the square root of 3 squared would yield 3. And here, the square root or the square of a square root is always the radicand, right? So this is 3x. And from this, you can easily see x equals 60. That's one way. Another way other people do this, say for example, this 4 can be introduced here inside the root by squaring it. So you could say this is the square root of 3 times 4 squared. And since this is square root of 3x, you can get rid of the, if you have two roots like this and they are equal, then the radicands must be the same, obviously, right? So you would say that 3 times 4 squared equals 3x. Again, same story, x equals 60. Okay, so 2 approaches. Well, it's just a matter of practicing with these kind of exercises. You will find plenty of them in the homework. Let's now talk about a couple of expressions. We will try and simplify some radicals, okay? But don't use a calculator for doing these exercises. Let's do some designated ones. For example, what is the value of x in this expression or in this equality? What is x? Oh, you change your response 3 times, Axel. The last one, right? Okay, Madeleine, 50. Okay, yeah, you're right. You're right. If you take squares on both sides, that is to say this would be x. Yes, Fabiana, 50 is the right answer. So you can see, square this, a square of 25, sorry, 5 is 25. The square of the square root of 2 is just 2. So 25 times 2, that is the value of x, 50. Okay, no problem. Now, people, what is the reduction of this root? 3 times the square root of 75. Don't forget to try the approach of factoring the radicand, right, as a product of prime numbers with their corresponding exponents. That would work faster, probably. Because it's a little difficult to write a symbol of a square root in the chat, okay? You can use this, okay? When you want to type a square root, use the name of the square root function in Excel. You can use this. Like this, right? For example, you want to write square root of 2, write this. If you don't have the symbol of root, which is a little difficult to produce. Okay? To deliver your answer. If we try the prime factorization, 75, you know, is 5 squared times 3. That is 25 times 3. So take the square root of this, and what you get is this, the square root of 5 squared times the square root of 3, right? Okay, this one, you know, it's 5 up to 2 over 2. That is 5 up to 1, simply 5. Now you have this. Multiply this, which is the value of the square root of 75 times the 3 outside, and you get 15 times the square root of 3. Okay, that would be the reduction. Okay, let's now talk about another topic, people, okay? Actually, we have like a very ambitious, how to say, set of topics for each class. Today, it's a little cramped because we actually had some time in our introduction, etc. But let's move over this topic, percents. We will see several model questions that you might meet up with in the SAT. For some of them, perhaps we will require some extra theory or tips that I'll share with you. So let's begin with this simple question. Example 1, Jacob got 50% of the questions correct on a 30 question test and 90% on a 50 question test. What percent of all questions did Jacob get correct? Okay, here it's just a matter of calculating it and type in the exam the correct value. Okay, here no choices, no answer choices. Please try to do this one. As you solve this one, okay, let me tell you something about the format of this question. When we talk about a percent, it's a number like this, right? It's a number, for example, X accompanied by this symbol that we all read percent, X percent. But indeed, the percent itself is this number. What we call percent in math is this part. So if you calculate the corresponding percent, don't input the percent in decimal format, okay? For example, if you find that the answer is 26%, in the box, you should input this number, for example, 26, because they are asking you what percent. So your answer is 26%, okay? Don't write 0.26. Otherwise, you would be saying that the answer is 0.26%. It's a totally different thing, okay? The percent is the number here, which indeed, this corresponds to a representation of a decimal fraction whose denominator is 100, and the denominator is the number we call the percent, right? Okay, don't forget about that. It's very important. Okay, this is not the correct answer, of course, here in this question, not 26. So what is it? Okay, several of you said 75. Is that the correct one? Yeah, okay, here it says that 50% of the 30 question test, that is 50% of 30, which is the same, right? 50 over 100 times 30, that is half of the 30, means 15. and 90% on a 50 question test. If you calculate 90%, 90 over 100 times 50, what you have here, right, is 9 over 10. You can simplify this 0 with this 0, so multiplication of fractions, and you get simply 9 times 5, that is 45. So how many questions did Jacob answer in total? Because it says, what percent of all questions did Jacob get correct? Normally, when you see this question format, what percent of B is A? That is, what percent of a quantity B is quantity A? What you need to do is this calculation, A over B times 100. This expression will give you the percent you're looking for. And the percent, as we said, is this number here. So what is B? B is all questions. So how many questions did he answer in total? The sum of 30 and 50, right? So you have, in the denominator, you have 80. In the numerator, how many questions did Jacob get correct? How many did he get correct? 50, 15 plus 45. So that is 60 over 80 times 100. Then you simplify this. This is 3 over 4. And 100 divided by 4, 25 times 3 equals 75. This is a percent, okay? This is the percent. This is the number you should input here, the answer to the question. All right, let's try another example question of percents in the SAT. Please, people, if you have any doubts or questions or anything or observations, please just let me know. Let's try this one. Example 2. Okay, let's read together. This is a typical paper-based SAT question in which you were given like some statement or initial information and then several questions related to that original statement. In the digital SAT, that will not happen anymore. That is, you have your statement and one question only, not like 2 here, but it's just practice. So this is your input. All of this, a record of driving violations by type and vehicle is shown below. You have like a chart here, table, and you have to answer 2 questions based on that data, okay? First one, which of the following is closest to the percent of recorded parking violations that were committed by trucks? Again, this is a relative percent question, right? So it's kind of a what percent of B is A? Something like that. You need to identify what is B, what is A in the question, and then do the operation A over B times 100, okay? That's a strategy. Okay, let's try to solve part 1. Now remember, also here there is a key expression, says is closest to. It means that they're looking not for an exact value, but an approximate value, okay? An approximation is valid here. No problem. Okay, thank you, Luciana. You actually responded the first one. What is the correct answer? Oh, Luciana you changed your answer. Actually, I think the first one was correct. Take a look. First, let's identify terms in the question. Which of the following is closest to the percent of recorded parking violations that were committed? It says by trucks. Take a look. If you first identify the number of recorded parking violations in total, what is this? Recorded parking violations. In the table, the total parking violations is 43. So this is our denominator. Then that were committed by trucks, that is our A quantity, right? Parking violations committed by trucks are 17. So 17 over 43 times 100. Okay, if you use the calculator, let's do it together. Okay, 17 divided by 43 equals this 0.3953. Okay, it's an infinite number, but okay, multiplying by 100, it means shifting, you know, the decimal point 2 positions to the left. So this would yield approximately 39.50 something, right? So this is closest to 40%. All right, you can try now part 2, question 2 for this table. Notice that again here, they're asking us to do some estimation only, right? So no need to find an exact value that corresponds or matches one of the 4 answer choices. The closest one to one of the answer choices would be the right answer, okay? What could be a strategy here in this question? Since we are talking about a number of very high, you know, a number of total violations in a certain state, 2,000 compared to the table, which only records 284 violations, driving violations, our strategy could be like this. Imagine that the table is giving you the information in a sample, okay, of a population. For example, a whole state. And then we want to estimate what would be the number of speeding violations out of the number of total violations. Can we try to estimate what that percentage would be in our sample that is in the table above? How can we do that? We can estimate the relative number or relative percent of speeding violations if we take the total number of car speeding violations, because it says speeding violations committed by cars. Here is this number. And we divide that by the total number of violations, which is 284. This one would be our A over B, right? And multiply by 100, that is a percent. Okay, if now this is the estimate percent of speeding violations by cars regarding the total number of violations, then we can multiply this percent by the total number of violations in the state. And this would yield actually the number of, the number of violations, right? If we multiply this is a percent, remember? This number is a percent, so if this we divide by 100 and then multiply by 2,000, it yields the estimate number of speeding violations by car in the state. Okay, this cancels with this, so it's just 83 over 284 times 2,000. If you do this in your calculator, then you get a value close to 585, option B. Okay, that would be the answer. Well then, percent questions in the SAT can have other variations. There is an interesting type of question that you may see. For example, this one. Take a look. The price of a dress is increased by 20%, then decreased by 40%, then increased by 25%. The final price is what percent of the original price? So what can you appreciate in this question in particular? Something happens about increases and decreases, right? We see like a series of consecutive percent changes applied over an initial amount. The price of some dress, we don't even know what's the price of that dress. But first, it's increased by 20%, then decreased by 40%, then increased by 25%. How can we find what would be the final price as a percent of the original price? In other words, what would be the equivalent of this sequence of 3 consecutive percent changes, increasing first by 20, then decreasing by 40, then increasing by 25 again, would be equivalent to doing which exact percent change to the original amount? How can we process this? Instead of trying to, for example, define some price for a dress and then find the price increase by 20, then increase it by 40, then increase by 25 in 3 consecutive stages, that would take forever. So don't do that in the SAT. Instead, use this theory, okay? Remember something. When you increase a number by some percent, for example, by X percent, that is the same as adding to a number A, the X percent of the same number A. But if you factor this expression, this sum, you get A times 1 plus X over 100. And if you give the expression in the parentheses the form of a fraction, then you get A multiplied by 100 plus X over 100. Now, the negative or minus sign you see there is just in case that instead of increasing by X percent, you would decrease the original amount by X percent. Just change the sign by minus or for minus rather than plus. So, what is the idea? The big idea here is whatever percent increase you want to apply on an initial amount, you can interpret that as a multiplication by some factor of this form. Use the plus sign if it is a percent increase. Use the minus sign if it is a percent decrease. Example, I want to increase quantity A by 25%. So what do? I multiply A by 100 plus 25 over 100, which is the same as multiplying A by 1.25, right? 125 over 100. If I want to decrease A by 17%, then this is the same as multiplying A by 100 minus 17 over 100. In other words, this is the same as multiplying A by 83 over 100 or multiplying A by 0.83. And that can be done also with consecutive percents. Example, if you want to increase P by X percent, then decrease the result by Y percent, and finally increase the result by Z percent, the expression that would yield the final amount after all these changes is P times this factor, which represents the increase of X percent, 100 plus X over 100, then multiply by this 100 minus Y over 100, and then by this 100 plus Z over 100. These factors represent the 3 consecutive percent changes. So you can use this same strategy to solve this question. Will you try? Okay, let's see what you get. Let's make a pause for a moment here. Oh, by the way, we said we would do like a break, right? Okay, do you want to take a break or you want to go till the end, all the way? Who is in favor of a break? No breaks? Okay. If you want to take a break, perhaps we can come back at 8:30. Sorry, 6:30. It's 6:25. We can come back in a moment. Perhaps you need to go to the toilet, I don't know. Or perhaps go for some water. Okay? Let's do a pause here as you continue trying to solve this question. If you want, okay, we'll come back at 6:30, okay, to continue with the last part of the class. Okay, so we come back and we continue with the solution to this question. Notice that using the same strategy, right, for applying consecutive percent changes to an initial quantity. In this case, we might define P to be the original price of the dress. So Increasing it by 20% is multiplying by the factor 100 plus 20 over 100, or 1.2. Then decreasing by 40% is the same as multiplying by the factor 100 minus 40 over 100, or 60%, or 0.60. And increasing by 25 thereafter is the same as multiplying by 1.25. So if you multiply the three factors, what we get is 0.9. So it's to say that the final price is actually the original price multiplied by 0.9. So this is the same as saying 90% of the original price. The correct answer would be 90. Okay, so that's it. Okay, let's keep going. Let's try now example number 4. Okay, example number 4. Jonas has a savings account that earns 3% interest compounded annually. Her initial deposit was $1,000. Which of the following expressions gives the value of the account after 10 years? This is an interesting variation of percent questions. It's about compound interest calculation. It uses the concept of percent. How can we deal with this kind of question? Here's a little theory you can apply. Take a look. When you calculate compound interest, okay, for an initial investment amount, let's call that the principal, okay, there is a formula that can yield the total balance. That is the total money you will find in your savings account, for example, including the principal plus all the interest earned by the money, the initial investment. And that formula is this: the total balance is the principal multiplied by this factor, which is 1 plus the interest rate expressed as a percent, and up to the duration of the investment, which is the number of periods in which you actually receive additional interest. Okay, so this formula has different variations, but the idea is this. Usually in these problems, you will be given interest rate, which is typically an annual rate, okay, here. You will be given the frequency of accumulation of interest, which is indicated by the phrase compounded and some frequency adverb. It could be compounded annually. That means the interest is computed and earned every year, or it could be every quarter, quarterly, or every month, monthly, or every semester, semi-annually. Okay, then there is also, of course, the duration of the investment, which is usually given in years or any other time units. Here, 10 years is the duration, is our time. And so how do we do to calculate the value, the total balance in an account where we are investing using compound interest? What you need to do once you identify the annual interest rate is calculate a modified rate, which corresponds to the rate for the period in which the interest is, how to say, computed. For example, it says compounded quarterly, so calculate the rate for every quarter. How to do that? Simply divide the annual rate by the number of quarters in 1 year, that is 4, and you get this one. Now, what about the duration of the investment? It could be in any type of units, time units. Imagine they tell you 2 years. How can you calculate the exponent here in this part? Okay, the number of times which your money will make or earn some interest in these 2 years is the number of quarters that exist in 2 years. How many quarters exist in 2 years? 8. So this is the exponent you will use in the formula of the compound interest. And the interest rate here is the modified rate. So let's say that my principal is P, okay? I want to know my total balance for this annual rate compounded quarterly for a duration of 2 years. So my calculation would be, okay, for this case number 1, would be this. Would be P multiplied by 1 plus 3 over 100, or 0.03 if you will, up to 8. You can do this with your calculator, no problem, right? Or this can be expressed as P times 1.03 up to 8. That would be the total balance in the account. Second example, if you have an investment amount set to earn interest at a rate of 24% annually, but compounded monthly for a duration of 1 semester, then you need to do this. First, using this annual rate, calculate a modified monthly rate. Divide 24 by 12, you get 2. The duration of the investment, express it in months. Why months? Because it says that the interest is compounded monthly. So now I have the initial investment amount, P, multiplied by 1 plus this modified rate, 0.02, up to this exponent. The duration of the investment expressing months, 6 months. So the expression that gives me the final balance would be this. Third example, if I have P dollars set to earn interest at this annual rate, but compounded semi-annually for a duration of 1 year, then my modified semi-annual rate would be 8%, divide 16 by 2. The duration of the investment in semesters is 2 semesters, so do this. P times 1.08, that is 1 plus 8%, up to this exponent here, 2. And this would be the answer. So considering these 3 examples, what would be the correct answer to this question? Okay, I'll leave you 1 minute. Okay, so what's the answer here? Notice if we identify the terms in the question following the examples in the table, what is our principal? It says the initial deposit was 1,000, right? So the value of P is 1,000. What is the interest rate? It's given as 3%. This is an annual interest rate, and it says compounded annually. So we don't need to calculate the modified rate because the interest is earned every year. So the modified rate continues to be the same because it's compounded annually. All right. The duration of the investment, 10 years. So we can use directly this value. The number of periods would be 10 because the interest is earned every year. So the expression would be, according to this formula here, right? It would be 1,000 multiplied by 1 plus the modified rate, which is 3%, 0.03, up to the number of periods, which is 10. So we get 1,000 times 1.03 up to 10. Option D. Okay, let's try one more example for more practice. Try this example 5. Same theory. Okay, just for you to get the correct theory, this is the example we set. Okay, remember that the interest rate that is usually given as an annual rate, you can modify it by identifying the expression compounded and the frequency adverb. It could be annually, quarterly, monthly, semi-annually. So this will take you, guide you how to calculate the modified rate. For example, if it is quarterly, divide the annual rate by 4. You get your quarterly rate. And the duration of the investment, express it in numbers of periods in which the interest is accumulated. For example, 2 years expressed in quarters. And in the formula, use this rate and use this number as the exponent, okay? The principal is always the initial investment amount. Total balance is the principal plus all the interest earned, okay? That is always the principal plus the interest earned. Let's try like a group approach in this question. Let's identify together all the terms for the calculation of this compound interest question. What is okay, the principal is easy, right? We all know that it's 400, the investment amount. What is the interest or the annual interest rate in the text of this question? What is the value here? 5%, very good. What is the frequency of interest accumulation? Look for the phrase compounded sum. Here, semi-annually, so semi. So if it is a semi-annual compounding of the interest and the interest rate is 5%, what would be the modified rate? That is the semi-annual rate. What would be this value here? Excellent, 2.5%. Now, the duration of the investment, what is the duration of the investment in this question? It's the time after which we want to check the money in the account. What is that? Is it a number? T years, very good, T. And so, in T years, how many semesters, half years exist? How many semesters in T years? Why semesters? Because it says semi-annually. So every semester, the interest is created. Imagine, in 5 years, 10 semesters. In 15 years, 30 semesters. In 3 years, 6 semesters. So in T years, how many semesters? 2T, very good. So all we need to do now is simply take this and this to the formula. Okay, this is the exponent. This one is the interest rate. So we would have that the final balance in the account, A, that is our total balance. This is our A in the question, would be the principal, that is our $400 initial investment, times 1 plus 2.5%, 2.5 over 100, up to 2T. But this one, 2.5 over 100, means actually this one, 1.025. So, option D, the correct one. All right, please remember this formula. Okay, this is a compound interest calculation. You can always resort to this. But there is also simple interest. But simple interest is much simpler. Okay, let's take a look. It says an investor decides to offer a business owner a $20,000 loan at a simple interest of 5% per year. Which of the following functions gives the total amount A in dollars the investor will receive when the loan is repaid after 30 years? Notice that if you want to solve a simple interest question, you can take this approach. For calculating the simple interest on some initial investment amount or principal, this interest is always a product. The principal, the initial investment amount, multiply by the interest rate expressed as a percent and multiply by the duration of the investment. But remember, here, okay, we can represent the interest rate as R percent, time T, principal P. And so this formula can be summarized as this. The total balance after some time is the principal times 1, if you factor principal here, times 1 plus the interest rate multiplied by the time. This is the formula you need to use. But be careful, the interest rate, if it is annual, okay, the time should be years. If the interest rate is like semi-annual, the time should be semesters and so on. So here, what would be our principal? Okay, we know this is what you borrowed, $20,000. And the interest rate here, 5% per year. Okay, we have our rate, which gives the total amount, that is the total balance the investor will receive when the loan is repaid. Okay, here, following this, we have 20,000 multiplied by 1 plus, what is the interest rate? is 5%, so 0.05. And what is the time? Okay, T years, no problem. So T, this is 20,000 times 1.05 times T. Option C. Okay, that's it. Formula for this is, remember, simple interest. The other one was compound interest, all right? A typical question with percents. Let's try one more. Here, this one. Okay, this is not about interest anymore. It's just percents. Try this one. This year, the chickens on a farm laid 30% less eggs than they did last year. If they laid 3,500 eggs this year, how many did they lay last year? That's the question. All right, Axel, good. That's a correct answer. Very good. Yeah, you can go like this. Define this as a variable, x, this year. Last year, say y. So it says that this year, the chickens laid 30% less eggs. That is, the number of eggs last year decreased by 30%. In other words, x equals y, the amount last year, the amount of eggs last year, multiply by 0.70. This is the factor, right? Remember, when you want to decrease something by 30%, this is equal to multiplying by 100 minus 30 over 100, which is 70 over 100 or 0.70. Okay, so this is it. Now say if they let 3,500 this year, that is the value of this one is 3,500. So what is, sorry, X is this year. This one is this, not the other way. Oh, I cannot. Not this one. Okay, 3,500 equals 0.70 y. And thus, y equals this. Okay, so this value is 5,000. Remember, you can use a calculator here, no problem. Let's try another. Example 8, in a particular store, the number of TVs sold the week of Black Friday was 685. The number of TV sold the following week was 500. TV sales the week following Black Friday were what percent less than TV sales the week of Black Friday? When they ask you the percent change between two quantities, right? Because it says we need to find what percent less, what the difference in percent between the two quantities of TVs. You can always try this formula. Okay? To calculate the percent change of two quantities, that is a percent increase or percent decrease between two quantities, for example, A and B, okay? This percent change, which could be a percent increase or percent decrease, you can calculate like this formula. Try to express this change or difference between the two as a percent of the original amount. That is, take the difference of the new value and the old value, divide by the old value, and this quotient multiply by 100. Okay, say for example, this item cost $80, now it costs $120. How much did it increase in percent? So you just do 120 minus 80 over 80 times 100. This is 40, right? Over 80, that is 1/2 times 100, gives you 50. 50 what? 50%. That is to say, if your favorite item cost $80 last month and now it costs 120, it went up 50%. Okay, so that's what you can try in this question. It says rounded to the nearest percent, okay? So rounded to the units, that percent value. All right, good. How do we get this one? Okay, do the same with the formula. 500 minus 685. Remember that the original, says the week following Black Friday, where what percent says the week of Black Friday, right? So if you do this, the new value is 500 because the following week, right? This week, 685. So this is a negative difference dividing by the original amount in Black Friday, 685. This is, as a percent, gives you something close to negative 0.27, right? Negative means it's a percent decrease. So this is the correct one. Okay. Always based this difference between two quantities based on the original or the older quantity. Okay, now before we just run out of time, I want to consider something. It's just a presentation of a concept that you will see in the here. It's exponential growth. What is exponential growth? Exponential growth is a situation where, for example, like in compound interest, right? Some quantity is increased multiplying by a factor every period of time, like in a compound interest situation, when a bank account, for example, earns 5% every year, you multiply repeatedly the initial amount by 1.05. Or if they say that the population of ants double every month, that is to say, this is exponential growth. And usually the exponential growth curve is like this, right? You have to remember that a curve where you can plot this in an XY plane has always this formula. Y equals a constant value multiplied by x up to t, where usually t is the number of periods of time, right? X is some variable. It usually represents some initial amount, and y is like, for example, in this case, right? We talk about the population of ants. Imagine that we start with 100 ants and the ants double every month. So this here is the factor, right? By which we multiply the ants every month. This is the number of times that we would do that. And this represents the, actually, the final population after t periods of time. So the curve is plotted between y and t, not x, by the way. X here is a constant value. So this would be this kind of curve. Exponential growth is like this, but linear growth is the other way. It's like this, is a constant growth every period of time, right? The opposite, if we talk about like, a decrease in the number, but in an exponential way, this is called exponential decay, right? Notice that this curve, when intersected with this, means simply this value is the value of y at the beginning when t equals 0. So if you, in this equation, replace t for 0, you get y equals a. So it's the initial size of the quantity we are mapping, right? For example, mass, the mass of a radioactive element. Same here, we talk about linear decay, okay? Linear decay is when some variable decreases over time in a constant way. We can map it with a linear equation with a single variable, such as this, for example. Okay, there will be a time where we'll study these linear equations and how to deal with their properties. Not today, it's just the concept you need to be familiar with. Thank you for your participation, okay? It was very good today. Take good care, people.